Hey everybody, it's Mr. M here, and in this lesson we are going to learn how to find the surface area and the volume of cones. So first of all, we talked about what cones are already, but let me explain it again. A cone is similar to a pyramid, but it has a circular base. And for our problems and our examples, we're only going to deal with right circular cones. So there are oblique cones where this would be slanted right here. In other words, let me try to draw one out for you. You would get something like this, and it would be slanted like that, kind of. Um, and then you can have cones that don't necessarily have a circular base. They can have some weird shape to them. And then as long as all these come up like that, to this apex, it would be a cone. But we're not going to deal with anything funky looking like that. We're just going to deal with a right circular cone, like an ice cream cone. So, in any case, this is the slant height right here. So, just like we'd had for pyramids, this would be the slant height, and this would be the base. In this case, it's going to be circular. The height would come down like this and be perpendicular to that circular radius down here in the middle of the center. And then this would be the lateral area, which would be around it. So the lateral area of a cone, we can find it to be pi RL. Well, what is L? L is the slant height. So pi times the radius times L. If you want to know exactly how this comes about, you could set up a proportion such as this, the area of a sector, area of a circle, arc length to circumference length, and then you would get the area of the circle here if I cut the cone out and unfolded it. So I'm going to cut the base out. There's a base. I'm going to cut a side out and unfold the cone, and that's what it would look like. And this piece would be the slant height right there. So you could set up a proportion and solve, and then you end up with the area of this sector right here will be pi RL. I'm not going to get into the nitty-gritty of this, but that's how you would do that. Okay, then the next thing we can find is the volume of a cone. So the volume of a cone is 1/3 times pi times the radius squared. So for the volume of a cone, it's 1/3 times pi times r squared times the height. It's similar to the pyramids that it has this 1/3 right there. Okay, and it's the same reasoning as we talked about with pyramids. So the volume of a cone is 1/3 times pi times the radius squared times the height. So 1/3 pi r squared h. And again, this is for a right circular based cone. So that's what we're going to deal with. Those are the only ones we're going to talk about. So only two formulas today: the lateral area of a cone, pi RL, and the volume of a cone. One more thing I want to add in here. What if we wanted to get the total area of the cone? Well, that would be pi RL plus the area of the base. So we would have the total area pi RL plus pi r squared. Okay, that would be the total area of a cone. Now, if you want to rewrite this, you can, and rewrite it in a different way by taking out the pi and the r. You get pi, so this is equivalent, pi times r, and then L plus r. You can write it like that. It means the same thing. All I did was take out a pi and an r. All right, so either way, it works. But this is the lateral area right here. And then the total area, we just add the base back in. So two formulas we learned today. Let's go ahead and just apply these formulas, see what kind of questions we're going to come across. Turn to page 347 in that student journal of yours, and then those are the example problems I'm going to do. All right, so let's take a look at this first problem. It says to find the surface area of the cone. Remember, when I say this surface area, I'm going to mean the total area. And the total area of a cone is pi RL. This is the lateral area, plus pi r squared. This is the area of the base. They give us a slant height here, which is L. They give us the radius there. So the total area here will be pi times 3 times the L, which is 5, plus pi times the radius is 3 squared. So the total area will end up being 15 pi plus 9 pi for a total of 24 pi square centimeters. All right, on the next problem, it says a right cone has a diameter of 1.8 and a height of 3, and we have to find the surface area. So we are looking at a cone again that looks like this, and this time the diameter all the way across is 1.8, so that means the radius here is going to be 0.9, and this height going up this way perpendicular is 3. Okay, so I'm going to take this apart because this piece that connects right there, that's going to be my slant height. This is 3, that's 1.9. I can solve for L because 3 squared plus 1.9 squared equals L squared. So I'm going to multiply, I'm going to add those up, and I just realized I put a 1 here, and that just is going to be 0.9. So I'll get 9 plus 0.81, square root of that is what L is. And that means L will come out to be 3.13. So now we have a total area of pi RL plus pi r squared. Total area will be pi times the radius of 0.9 times the slant height of 3.13 plus pi times the radius of 0.9 squared. Let's put this in our calculators and work it out. So 0.9 times the 3.13 comes out to be 2.817 pi plus 0.81 pi for a total of 3.627 pi. And you could change that by multiplying the pi through and get a decimal answer. So you can multiply by 3.14, but I'm going to leave it like this. And this would be square inches. All right, let's do the next one. So this one says, find the volume of the cone. Remember, the volume is going to be 1/3 the area of the base times the height. And on a cone, it's a circular base, so 1/3 pi r squared h. So the volume is 1/3 pi times 3 squared times the height, which is 4. This is the slant height, don't forget. So the volume ends up being 1/3 pi times 9 times 4. This will reduce to be a 3, so the volume will be 12 pi cubic centimeters. All right, moving on to number 4. A right cone has a radius, so it's a right cone, and they're telling us this radius is 5, and this slant height is 13, and we need to find the volume. Remember, volume is 1/3 pi r squared h. I don't know the h, but I do know that this piece is 5, and that's actually a Pythagorean triple, but I'll show you. So h squared plus 5 squared equals 13 squared. So h is going to be the square root of 169 minus 25, and that'll come out to be 12. It's a Pythagorean triple, so it'll be 144. Square root of that is 12. So the volume ends up being 1/3 pi, the radius is 5 squared, and then this height right here is 12. So let's finish this off. All I did was plug the numbers in. Remember, this was your radius, and then we solve for the height. This is the height, that's the slant height, just to remind you. So 1/3 pi times 25 times 12. This will reduce with that to make that a 4. So the volume will be 100 pi cubic feet. All right, on to the next one. Okay, so this time it says, a right cone has a surface area of 440 square inches and a radius of 7. Find its slant height. All right, so the surface area is 440. So remember, this is a total area, and that's 440, and that's equal to pi r L plus pi r squared. They tell me the radius is 7. I need to find the slant height. So 440 equals pi times 7 times L plus pi times 7 squared. So all I did was put in that radius. Let's finish the problem over here. 440 equals 7 pi L plus 49 pi. All right, so now I can subtract over the 49 pi, then divide by 7 pi. So I'll have 440 minus 49 pi equals 7 pi L. Over here, 440 minus 49 pi. Divide all this by the 7 pi, right? Because that'll reduce it out. And that will be my slant height. So now I'm just going to go ahead and do this on my calculator, and I'll just go ahead and use 3.14. So that's 440 minus 49 times 3.14. And that'll give me 286.14. And then divide that by 7 times 3.14. And I will get 13.018 is equal to L. And those are inches. All right, let's take a look at the next one. We got a couple more here to do. Okay, this one says, a right cone has a volume of 528 and a diameter of 12. Find its height. All right, so we know that the volume, we know that the volume is equal to 1/3 pi r squared h, since it's a cone. That's 528, 1/3 pi. The diameter is 12, so that means the radius is 6 times h. So this becomes 528 equals 1/3 pi times 36 times h. This will reduce with this to be 12. So then I will get 528 equals 12 pi times h. So h will be this 528 divided by 12 pi. And let's do that as a decimal. So this 528 divided by 12 times the 3.14 gives me 14.013, and those are meters. All right, next one. Cone A and cone B are similar. The radius of cone A is 4 and the radius of cone B is 10. So now it says the volume of cone A is 134 cubic meters. Find the volume B. So remember we said if we have side ratios, in this case the radius is like a part of it, it's a side, it's a one-dimensional shape, so centimeters. And if we wanted to do a volume ratio, we take this A to B and we cube it. So we will have, this will give us the volume right here. So what I'm saying is if you have cone A to cone B, this is 4 to 10 if I set it up like that. If I cube this ratio, I will get the volume ratio. So the volume of A, since cone A was 4, the volume of A is 134. Cone B was 10. The volume of B we don't know. And I can solve it from here. So let's go ahead and do that. So 4, I'm going to change it to a decimal. It's just easier. So 4 divided by 10 would be 0.4. And I'm going to take my 0.4 and then I'm going to cube that. So I'll get 0.064 equals 134 over VB. This is 1. If that bothers you, then go ahead and cube it right away and say 64 over 1,000 equals 134 over the volume B, and now cross multiply. So if it bothers you what I did, just do it this way. Regardless, the volume of B is going to be 134 divided by 0.064. Just like if I did here, it'd be 64 times the volume of B equals 1,000 times 134. Solve it from there. So your final answer will end up being 2093.75 centimeters. And finally, our last problem here, they want us to find the volume of this composite figure. Okay, so let's slide this up a little bit right here. And look at what I have. I have a cylinder and a cone. So I need the volume of the cylinder plus the volume of the cone is my total. Okay, over here, let's do the cylinder. The cylinder has a radius of 2. So the volume of a cylinder is pi r squared h, and this has a radius of 2 and a height right here of 5. Plus, this cone is 1/3 pi r squared h. So 1/3 times pi times my radius, which we said was 2 squared, times the height. They gave me the height of the cone, which is 4. So that's going to be my total volume. So this will end up being, this will be 4 times 5, so 20 pi, plus this becomes 4 times 4, 16 pi over 3. And if you wanted to keep it in pi form, that's great. Find a common denominator, which would be 3, so 16, and this would be 60. So you would end up with 76 over 3, so 76 pi over 3 cubic inches. If that bothers you, change this to a decimal. 20 times 3.14. Change this to a decimal. 16 times 3.14 divided by 3. And then give me a decimal answer. I will take either way when I have you do these on a test, unless I specify one way or another. But always know how to do it in pi form because it keeps it in a pure type of form. All right. So that's pretty much it. Hopefully cones typically aren't as hard as pyramids. Pyramids are usually a little bit more difficult. So thanks for watching. Hit that like and hit that subscribe button, and I'll see you guys in the next video.